All right, let's go ahead and start today's class. Let's make sure everybody is here. Those in chat, go ahead and say here. Okay. Looks we have most of the people here. All right, so I assume everybody was at least satisfied with their grade on the exam. So I did want to talk about some of the topics that were in the non-multiple choice questions, since those are the multiple choice have fairly straightforward answers. One thing I noticed was people saying that factory or builder is the quote-unquote best pattern for creating objects. And I want to make sure that we're clear that there's not a best methodology when it comes to these software design patterns. There is a best that fits a certain goals and limitations and criteria that you're looking for. So in some instances, when you have a very complex object with a lot of parameters that need to go into the constructor, in that case, a factory might be nice and useful if those parameters aren't variable, because then you can just put all of the parameters into a factory helper method and just call it and get your object back. But what happens when you need to have those parameters be variable? Like, let's say it's a button that you're going to click on. The button would have some type of corner radius on the edges. It's going to have a background color. It might have a text. If it has text, does it have a text color? Does it have an icon? Is there icon and text? And these variables, these parameters, when they're variable, a factory might not be the best scenario. In that case, a builder might be more useful to you. Does that make sense to everybody? That it really depends on the specific use case that you're talking about, which pattern might be more appropriate for different, might be better in that instance. Okay. So that was the first thing I wanted to talk about. I was very generous in the essays, or short answer essay questions about that. But I did want to point that out as one of the areas that, and I think that's a lot of you had the core concepts of what the design patterns were, but you actually did rather poor in describing them. So something you should always think about with a design pattern is, what is its purpose, what is it solving, and how is it constructed? Like those three, we'll call them columns of information. So what is the purpose? So let's take builder. It's to enable you to simplify the creation of an object that has a lot of variable constructor parameters. Awesome. How do you actually construct that? And then you would describe that. And what was the and then possibly you might want to give a compare contrast, depending on how the question is answered. What's the benefit of this pattern over this pattern? And we just did that for factory and builder. And so you have to understand the use case of really why you're doing that. And when you can start comparing different patterns to others, that's when you start actually being able to use them. Now, just being able to make a builder or make a factory, that's a good first step, and that was farther along than I was when I took this course. And so we're making good progress, and I think you're learning the fundamentals. I just want to make sure that you understand that there's more additional steps to go down that path. So, with that being said, oh, yes, the Git videos. Did everybody watch those? And did everybody has those installed and they were working on your system? You're able to push to GitHub? Okay. If you have it installed and you have it set up GitHub desktop on your app on your system, that's a little belt and suspenders actually. The GitHub desktop, I don't think it actually requires you to have normal just Git installed, but I highly recommend having both installed so that your system you can easily navigate through the command line. Because there are still commands that you can do in the command line that you can't do through the GitHub desktop application. It's dramatically improved over the last literal couple of months, but there's things that you can do from command line that you can't do in the app. And so also that the tutorial, was part of that first video, is setting up SSH keys. That's a super important skill set to have. It's actually it's a lot easier in Linux, but for Windows, learning how to use PuTTyGen and creating your SSH keys and storing them on the server is really useful. And then I would also highly recommend setting up two-factor authentication for GitHub through YubiKey or some other cryptographic means, then falling back to using an app on your device, and then falling back to the phone number. Phone numbers are a lot less secure, and apps are inconvenient because you could lose the phone, or the phone could break, and then you couldn't have access to your apps. So whenever you set up two-factor authentication, they're going to give you some codes to print off, and I do recommend actually printing those and storing them in a safe. If you don't have a safe, I would look into getting a fireproof safe if you can. Put your important documents in it. I put my important documents in a Ziploc and then put it in the safe. Because cheap fireproof safes aren't waterproof. So, just belt, suspenders, gaiters, and inflatable life raft, handling that type of stuff. So, just things to be aware of. Another turn of events, and I would have gone into IT security rather than programming, so I'm a little paranoid when it comes to security, which is what you should do. Just because you think people are out to get you doesn't mean they're not. So everybody got Git installed. Were you able to verify that you could push a repository up and then commits to a repository on GitHub? Because that's the real key, is being able to pull a repository and clone it, and then being able to push commits up to it. So If you haven't gotten that working, make sure you do go ahead and try that and become familiar with it. Spend literally a couple of hours watching my second video about the usage of Git and practicing. Become familiar with how to do a merge conflict. Understand the tooling. I personally like Meld because I like the 3-window solution. Left is local, right is remote, and center is the combination of the two. But that's personal preference. But it's what I recommend starting off with. Android Studio does the same thing. I'll show you that, but today I just wanted to briefly talk about that, see where you all were at, and then talk some more about the exam, basically catch up, and tell you where we're going to go the rest of the semester. Yeah, I don't have the making it work on a Mac actually should be easier. You should on Mac I just use the command line installer. I forget what it's called. It's not Homebrew, is it? I don't know. I use a Mac for work. Oh no. Yes, I know. It's in the terminal, but there's a separate application you install that allows you to install applications through the terminal. I don't have instructions on that. I'm sure if you go to YouTube or Google, you'll find instructions on how to set up Git on Mac. Yeah, okay. Yeah, I think it's Homebrew, but I don't have $5,000 to invest in a new MacBook Pro, so there's that issue. Because I'm already butting up against the 32 gigabyte limit on my desktop. So, I don't know. As an aside, the new MacBook Pros are unfortunately specifically designed to where you cannot get 64 gigs of RAM unless you spend $5,000. You have to get the full Max processor and everything. So that's a little insane to me. I'd much rather have a lower binned CPU and still have more RAM, but you can't do that. But that's, like I said, an aside. Yeah, so the nice thing about the terminal inside macOS is that macOS is a Unix-based operating system. So the basic commands that you would use in Unix or Linux will work in the Mac. It's just trying to determine which exact tool that you're going to use to install it with. But once it's installed, it's the same exact commands that you'll type into the git bash in Windows, which is just a Cygwin emulator of Linux, basically. So. Let's see. Oh, yes. About the upcoming remainder of the semester. I know people are curious. We did end up putting a bit more time up front in, like I said, we were building the foundation and making sure that we had solid foundation. That way we'd be able to build a sturdy house of knowledge. And so I want you to go ahead and make sure by the end of next week, have chapters 6 and 7 read out of the book. We've covered most of the material in this actually already. Let me pull it up and get the specifics. So 6 is methods and 7 is array lists. And we've pretty much talked about most of that. The biggest thing that we haven't talked about is multidimensional arrays. And so that would be a good thing to pick up and talk about. So make sure to read chapter 6 and 7 by the end of next week, and we'll cover up to chapter 10 by the next exam, and that will probably be the 2nd of December, I believe. I'll announce exactly when we're closer to that. That'll be right after the Thanksgiving break, or whatever they call it now. But yeah, we'll cover up to chapter 10, and then at the very end we'll talk about exceptions. And then chapter 14, we've sort of hinted at and talked about in class a fair amount. It covers strings and then regular expression. So the stuff between that, 12, 13 is GUI stuff, and then the stuff after that is more advanced and more Java-centric than it is purely object-oriented. Like generics. Generics work a little differently in Java than they do other languages, and lambdas and streams are new concepts in Java 8 and /9. But so I would recommend going through and reading through the rest of this book and understanding it. Some of the topics, like chapter 22, accessing databases, is super useful, but way beyond the scope of this individual class. But the thing I like about this book is this is a book I consider a desktop reference for Java. So, and a good guided tutorial for you to learn on your own these more advanced topics that aren't specifically tied to this course, but I wanted to give you the ability to look into on your own. If that makes sense. I hope that makes sense. So, another thing I wanted to talk about. I have a list up. I want to talk about if everybody would be fine getting a microphone, or having a microphone available. I assume everybody has a microphone, but having a microphone available during class, that way we can have class discussions with voice. I think it would speed up, particularly as now we're going to be moving into more of a discussion phase of how do you design classes and how do you create interfaces and things like that. I think that would be a nice option to promote promote interactivity. I'll put it that way. Not immediately. It would be nice if you could have it by the 16th. I don't want to require anybody have to spend any money. I'm just seeing if people have issues or not. Okay. Because otherwise we might need to... I'm not opposed to having classes in person as a concept, but some of these would do much better with more focused discussions rather than just what more one-way lecture like this is. So, that's the main question I had about like logistics of the class. So today I just wanted to talk about how you have some people typing. I assume everybody has a mic at least built into their laptop. I'm not asking for like a studio mic on a boom arm or anything nonsense like that. One requirement. You do need to wear earbuds or headphones or something like that. That way we don't get echo. And I guess that would be, doesn't have to be a headset, but a microphone and ear speakers, for lack of a better catch-all. We can talk about that. That's just something I've been brainstorming on how to improve interaction in the class. So, okay. I'm going to start talking today about how you design classes to be testable. We talked about briefly unit testing, and we showed how you can make a test, a unit test, and you could test a class. But that's just the beginning. You need to actually design your classes up front to be testable. Otherwise, they're not going to be good. Basically, you'll make your life a lot harder. I'm trying to think multiple things at the same time. Sorry. So, I'm just gonna fill in. You all can read that, right? I really do need to figure out how to Android increase contract font size. Oh well. At least I can change font size over here with the mouse now. But regardless, you guys can read this over here, or you all can read this over here, correct? Okay. So I'm going to talk about a specific pattern that's used a lot in Android. I believe maybe iOS can adopt this, but they don't have to. It's called MVVM, and MVVM stands for Model View View Model. And you'll start seeing these patterns that have long names that are built up of different components once you have mastered the software design patterns. This is a much more advanced topic, but it shows why Okay. So here's a simple singleton, non-thread safe. Well, actually, it might be, but non-lazy at least. I'll talk about that later at some point, or maybe in a different class. But notice static works before and after. You'll like to pick a pattern, whatever your personal preference is. You'll find one that you like personally. I personally like static first. That's just me. So here's a repository, and just like the Git repository, hence the naming, it can store data. Public Git text. We'll just make up numbers. Doesn't matter. Text. Return. Hello. That's the repository. Now let's take let's make the view model. And don't worry if we don't get to this entirely this class. This is a complex example, but I think inherently it'll do a lot of good to show you this, because it'll show you the importance of understanding these patterns and the nuance of understanding how to design patterns to be testable. So we're going to check off a bunch of things through this example, but I just need to go ahead and type it up real quick. So here's the view model. In a 5-second explanation of a view model is, it is what stores the state of a view and has the logic for that view built into it. And why would you do that? I'll explain more at another time. But for now, this stores the state and has the logic in it. We'll just go there. We'll just explain it that way. State and logic in it. So, private int text color private string text just text. Okay. I don't. Yeah, I didn't think it had that access to that. That's an Android component. Yep, not live yet either. So, how do we want to set this? You know what? We'll just. Yeah, I won't cheat. I'll do this a better way. Public string get text. Okay. And then we come down here. We'll just call this view. Oh, excuse me. There's our default constructor. Okay. So, let's just pretend, and I'm skipping a lot of context here, but let's just pretend this is a UI widget. And this is how Android Studio or Android is generally done when you're building custom views. Here's the view model. Oh, let me rename this. There we go. Just so it's consistent. Here's the MVVM view, here's the view model, and here's the repo. Okay. So if we wanted to test this view, well, that's hard because if you think about it, a view or a UI widget is something you interact with. Let's say this is some type of button. Well, how do you interact with clicking a button? Or how do you know that the button's text is hello MVVM, or the text color is, I think we said it was 43, 45. How do you test that? And that's an interesting concept because there's a lot of possible solutions, but it realistically, and the reason this pattern exists is you don't have the view model deciding what its colors and its state are. You don't have the view deciding that. You have the view model deciding that. And what that does is it creates a separation. So you have the view over here and you have the view model over here. Theoretically, as long as the view is programmed correctly, you can automatically link them together, and all of the state from the view model will affect the view. Does that make sense to everybody? Conceptually, this isn't that difficult. It's just something that you might not be aware of. And this is a super simple example. I actually wanted to do this in just regular Java. That way we avoid a lot of the syntax sugar that Android has that wouldn't be clear, basically. Okay. So here's the view model, and you notice we have a getter for text and color, but we don't have where it's pulling the values from the repository. So one way of doing that is mvvm repo.get instance that mvvm repo. There. So this isn't terrible. Now notice there's some repeated code. Anytime you see repeated code, think to yourself, I wonder if that needs to be repeated, or if I extract that out into a separate piece of logic, would that be better? But we'll skip that for right now. That's something to always keep in the back of your mind. All right, so here's something interesting. okay, you have your text color. It came from the view model, or your text came from the view model. Let's click on the view model. Your text came from the repo. Okay. How do you test that the repo is giving you the right information? Or, more importantly, how do you test that this logic in here, this class, isn't messing up the information it's getting from the repository? I don't expect anybody to actually have an answer right now, a proper one, but it isn't something I do want you to think about for a second. Well, if you don't already know the answer, it's going to be rather difficult for you with this limited amount of unit testing experience to come up with it on your own. And that's fine. Testing and designing classes is a lot of apprenticeship type of learning, where you're going to see what others do and copy it for a long time. And when you can understand why they're doing what they're doing, that's when you can become apprenticeship level and then actually enter the trade yourself. So, does that make sense to everybody? It's a little ambiguous, I understand that. But everybody understands these three classes, what I'm doing here with these three classes, right? Here's a repository. It's where you get data from. Here's the view model. This is going to get our data from the repository or wherever, and it's going to process it. There's no processing yet. Like, we need to actually add that. And then here's the view. The view is what's going to display it in some way. Now, here's the nice thing. Why am I separating out these pieces? Does anybody have some guesses? I sort of hinted at it and I gave some answers. So let's go ahead and see if anybody can come up with, even remembers what I said, or can come up with what would be good ideas of why to separate these out. Everybody can just give a suggestion, what you say, or what you think. There's no right answers or wrong answers at this point. Except that answer. That's wrong. No, I'm kidding. Okay. I'm kidding. So we have one answer saying maybe it would make it easier to find a bug. Okay, that's actually correct. Expand upon that. Easier to work in groups. Excellent answer. So it can be worked on by different people. Yes. All of these are true. So it can be worked on by different people, and so it can be worked on in groups, are actually two different answers, but probably didn't mean it that way. So it can be worked on different people is true in multiple senses. You want the original developer to be able to split out the code among many developers, so that's what we call going wide. And then, in addition, you want multiple people to be able to look at this class and understand what it's doing in the future so they can edit it and update it. Because code doesn't just sit there and is never updated. Even programs like ls, which are list on Linux, are still occasionally updated to fix bugs or add new enhancements, even though they're at this point 40, maybe 50 years old. So, is it? Let's see. So it can be worked on. Does that make sense? That there's different ways of viewing that answer. Probably the person didn't mean it that way, but it's good to think of it in multiple angles. Is it front end, back end split up now? Like, would views be front end, rest back end, or do I not understand those terms well? So you're sort of right. The logic behind what you're saying is correct. However, front end and back end, the way they're generally meant nowadays is front end is what the user is interacting with, and back end is servers, almost exclusively. Like the company I work for, that's how we split it up. Front end is generally web, and then mobile is a different thing. It's just sort of how people want to subdivide it. Unfortunately, computers, one of the hardest things is naming things. So here's a perfect example of why it's hard to name things. Let's say you're a physicist and there's a giant hole in space and it's black. What are you going to call that? A black hole. Okay, there's a giant white star, but it's small. White dwarf. Like, there's a big red sun or star. It's giant, red giant. Okay. Computer science is a lot more ambiguous in a lot of ways. The good thing about computer science is, other than a lot of the core terminology, like algorithm being Arabic in origin, because of world history, but a lot of computer science advancements are done in English. Most programming is done in English. There are exceptions, in particular in former Soviet bloc and in China, where they purposely pursue a Chinese variant, entirely Chinese language operating systems and things like that. But because it's in English, and I believe we're all native English speakers, I don't even do that well, I admit. Hey, you grew up in North Carolina, then come to Ohio for school, and let's see how many years of speech therapy you go through. But true story, actually. But anyways, the worst thing I do is sometimes I will wash clothes, because my mom still uses wash, despite the fact she was born and raised here in Youngstown, but she lived in North Carolina enough years to pick up that one. Anyways, so back on track. Naming things is hard, so let's take something that's in the news a lot right now, is all these digital currencies and NFTs, and let's pretend you were going to make a system like that. Okay, you're what company was it? Is it Armor Games? Maybe not. There's games Ubisoft is one of them. They're going to be incorporating NFTs and blockchain into future versions of their games in some unspoken about ways. Okay, let's pretend you're on that development team and you're in charge of designing the system. Great. Have fun. But let's just start naming some core features. Okay, well, you're going to have a trade. Okay, there's going to be some trade object that exists in a database, and it exists in a web API that you access, and there's going to be objects on the mobile and on web that they parse the trade into. Think about how you name the trade offerer and the trade recipient. We can just call them offerer and recipient. Okay. What happens with a counter trade offer? So you have person A and person B. A wants to trade, we'll just pretend they're Pokemon cards, a Charizard for a Squirtle or whatever. Somebody's winning in that trade, but that's besides the point. The person getting the Squirtle says, "Oh no, I want Squirtle with the sunglasses." So they make a counter trade offer. Do you change the numbers or the user IDs of who the trade originated from? How do you name these transactions? How do you do this type of work? And so naming things gets really complicated in programming, computer science, because you have to come up with a taxonomy of the entire model of what you're doing. And those are big words, but basically you have to name all the different parts and things that you're doing in your system. And so if you can't name all the things in your system and you can't name all the actions those things can do, then you're going to run into trouble. Does that make sense? That's a sort of convoluted example. And I switched metaphor 18 times. But hey, ADHD. So, whatever. I kept refining it and improving it. So I hope that makes sense. But back on track. This example here, I literally do this all the time. So I know what the naming should be and whatnot. So it's not that big of a deal. Okay. So here, let's go ahead and private repo equals MVVM repo. Oh. So you'll notice I'm messing up the typing of the things I'm doing in Java. And the reason I'm doing that is because I've been practicing a lot more in Kotlin. And in Kotlin, you don't put the type first. And so I'm getting really confused from muscle memory of what. I'm like, this should work. Why? Oh, yes, that's why. Because I'm forgetting how to do what I was trying to do. So here's something. We can replace the repo with a single instance. If you can, generally, you're going to improve your code when you can do things like that. When you have, and this is a really simple example, this is only it actually tells you down at the bottom right of the screen, this is 22 characters versus 4 and 4. Technically, there's more characters on the screen and more lines, but we could do this. And now having this line actually saves overall characters. Does that make sense of why you would want to simplify this like that? So, this isn't actually where I'd want to get with this, but it's an intermediary step of being able to make this class testable. We'll get there. Let's look at the constructor. Now, as you should remember, default constructors are auto-generated for you. we don't actually have to type this. It would be there for us. So the comment is, doing that will ultimately save you time later when crafting your code. Yes. And it will actually really help me when I am working to make my code testable. There are some really, really nice things in Kotlin and other programming languages that Java can't yet do, and Java really needs to catch up and be able to do this. So in Kotlin, and this is just, let's just follow the logic of this. This isn't proper Java syntax. Is that clear to everybody? So in Kotlin, you can do this. And it's perfectly legal syntax, sort of. Like, you obviously have to change the syntax to be Kotlin, but you can have, like, here's proper. Why is this an issue? Oh, that's an issue because there's no example for default constructor. Notice, when I said it will auto-generate a default constructor, it'll only auto-create a default constructor if there's no other constructors at all. But as soon as you start making a constructor, come back here, it won't auto-generate the empty one for us anymore. And actually, we can come down here and it'll create the constructor for us. So, something to be aware of. So, oops. In Kotlin, you could do this, and you wouldn't have to pass in the repo because there's a default value for it. So that's really a really nice feature of Kotlin. It's honestly one of the nicest features, and it saves you a lot of repeated code, basically. But let's go ahead and delete this for an instance, and we come back here to our view. Well, how do we make our view actually work? New. Get instance. Oh, ha ha ha. There we go. You would actually do this. And you would make the constructor private so that in the view, you can't do this. You would make that illegal. Instead, you would pass in the repo here. Does that make sense? Now, our view model is defined with a repository. We come over here. We have our repo is passed in. So when we're making guess that isn't built in by default. Interesting. So as you just saw, I typed an annotation that apparently you need to import into your Gradle to be able to use. I didn't realize that. Oh, yeah. Oh, it's an Android annotation. Interesting. Well, Android has this option. You can call it non-null, and so it'll check to make sure the repo passed in isn't null. I thought that was a Java feature. It might have it too. I'll have to look into that. So now when you're creating your tests, test. Yeah, there we go. I think that's what it should give you. Yes, that is correct. So, let's run this. Okay, this repo. Interesting. I'm obviously missing something silly that I'm not seeing where the source of this is. Oh, interesting. Not sure why passing it in didn't work. I have to figure that out. One of the drawbacks of coding live, you can run into weird issues like that and kind of stun lock yourself. So it should work. Like, that was the point of this. Not static. That means this. Interesting. Obviously, what this means is I have an issue with my repo not working correctly. Actually, Get Instant should be working. I don't know. Regardless, we'll figure that out. I'll have this cleaned up by next class, and it'll make it make sense. But the point of this is, despite it not working right now, is that Is repo null? Oh, it's not null. Interesting. I'm obviously missing something basic that I am not thinking of off the top of my head. Anyways, I will figure this out, and the concept is that you want to create classes where you pass in the things that this class depends on. What that means is that you can test this class by passing in different instances of the repo. And as you look in here, there's no strings in this class that will say, let me make it full text. You don't need that. There's no actual string literals in this class about where the text is. So you can test the logic of this view model class without having to be that concerned with what the text is immediately. And then you could also, we can do a lot of things with this and build this off and show some really complicated concepts for testing. But it all depends upon, and I need to figure out why this passing it in isn't working right. Like, this should work. Yeah, I'll figure this out. I'm obviously missing something simple. But, no, it's not anything in my test file. This is one of those scenarios where if it was a snake, I'd be dead because it would have bitten me like 10 minutes ago. So, but regardless, the point is the idea of designing your object-oriented classes in a way that promotes testability. And this is a concept that really is trial and error because you can go overboard. You definitely can. And that going overboard might make your code harder to use in the first place. So you have to learn how to balance these things. Like, here's the repository. Notice it doesn't have any interfaces or extend anything. That's a problem. I'll let you think about it over the weekend and think about why we would want to have an interface here. What benefits does that give us? What can we do with an interface here that we can't do with just a single class? But with that, we have about 5 minutes left in class, and I will let you go or if you have any questions, I'll be here. But with that, we'll generally go ahead and end this class, and I think we're on a pretty good track. Like I said, make sure to read chapters 6 and 7 by end of next week, and then we'll be on the track to cover the core bulk of material I wanted to cover this semester, and also touch upon these topics such as get, unit testing. Regular expression was something I just like to throw in as a skill. I actually have a example of using regular expression to auto-generate code, which is something we'll talk about in the next class too. I'll briefly demo it. Does anybody have any questions? All right, if you don't have any questions, we'll go ahead and end it there. Oh, now we have late typers. Oh, all right, they're just saying see you Tuesday and other things like that. All right, everyone, have a good evening and have a good weekend.